Hello there, welcome to my channel on chemistry lessons. This is an A-level chemistry lesson and it's going to look at the boiling points of alkanes. First up though, if you don't subscribe, please do. Your support is very much appreciated. Please use the like and the comments features. Let me know what you think. So by the end of this video then, we're going to be able to explain how the chain length and chain isomerism affects the boiling point. Now, if you haven't seen the video on isomerism, it is a good place to start, and I will put a link in the description below. Some prior knowledge to start then. So from our topic on bonding, we should know that carbon-hydrogen bonds are non-polar. Carbon-carbon bonds are also non-polar. This means that alkane molecules are all non-polar and therefore only have van der Waals forces of attraction between molecules. What we also learnt when we looked at van der Waals forces was that bigger molecular mass means more electrons, which leads to stronger van der Waals forces and higher boiling points. Let's start with chain length because this is quite an easy one. Longer chains have higher boiling points than shorter chains. And that's simply because longer chains are bigger molecules. They have bigger molecular masses, they have more contact points, and therefore stronger van der Waals forces of attraction. And that means that more energy is required to overcome those forces of attractions. So let's kind of look at an example here. I'm going to do the skeletal formula for butane, skeletal formula for hexane. Now if we look at the van der Waals forces between two molecules, you can see that there's more contact points on a bigger molecule, and bigger molecules have more electrons. So not only do they have more electrons, have more contact points, so longer chains will have more and stronger van der Waals forces, which means more energy is needed to overcome them, which means more energy or a higher boiling point for a longer chain. So branched versus straight chain then. It's a little bit harder to explain this one. So we've seen previously that structural isomers do have different properties. We're going to see that straight chain isomers actually have higher boiling points than branched chain because they have more contact points, which leads to stronger van der Waals forces, which means more energy is required to overcome them, leading to a higher boiling point. Now let me give you an example. So I'm going to do straight chain hexane. 1, 2, 3, 4, 5, 6. There's straight chain hexane. If I look at a branched form, such as 2,3-dimethyl butane, they both have the same molecular formula, which would be C6H14. But because they've got different carbon chains, these are chain isomers. The one on the right would be classed as a straight chain isomer. The one on the left is a branched isomer. Now they have the same molecular mass because they have the same molecular formula. However, the molecule on the left, you can see, actually have less contact points. So although they have the same number of electrons, they actually have less contact points, which is going to lead to weaker van der Waals forces of attraction. So if we just compare straight chain versus branched chain with the same molecular formula, we can see that the straight chain will have more contact points, more van der Waals, which means more energy being required to overcome them, which means straight chain isomers have higher boiling points than branched chain isomers. And that's the end of this video. Hopefully that was useful. Thanks for watching.